treat this very interesting topic, indices. It's a very, very interesting topic on indices. So let's just wait for like a minute or two while others join us. If you have been following this channel for a while, well, it's been like 2 or 3 weeks now that have come live, and we'll be talking about trigonometry, but I might have to revisit that topic. But for now, I just want to do indices from start to finish. So good to have you here. If you are here joining us in this live, please type 1 in the comments. Let's have you know that you are here for us and you are here with us. So type 1 in the comments so that we can get this started. Type 1 in the comments so we can get it rolling. Type 1 in the comments. Type 1 in the comments. Okay. Let's have you join us. We have some very interesting questions and concepts that we'll be covering under this topic, indices. So when we say indices, we are talking about exponents, right? We're talking about exponents. For example, if you have 2 raised to the power of 3, the index here is 3. Yeah, so 3 is the index or exponent. So when you say 2 raised to the power of 3, this means 2 times 2 times 2, which is what? 8. So this is what we call repeated multiplication. Repeated multiplication. Okay, let's wait for other people to join us. If you are coming here live with us, you are welcome. Welcome on board. You are welcome. Indices. We're going to start with the laws of indices. Laws of indices. So there are different laws that will help you carry out operations involving indices. Let me say that again. There are different laws that will help us carry out indices, that will help you carry out operations involving indices. There are different laws. Please, if you are joining us, thank you. You're welcome. Please, let's like the live. This is Gpad Learn Math. Let's like the live. Let us like the live. Let's like the live. So good to have all of you here. Now let's begin. Since we have 5 people already join us, it's so great to have you here. Please share the live, like the live, comment, and support so we'll have more people join us as we begin this very interesting topic on indices. So like I said, we'll be talking about the laws of indices. If you understand the laws very well, you can use the laws. Those laws can be applied when you have problems that would demand that law. You have multiplication law, you have division law, and so on and so forth. So if you understand those laws very well, you'll be able to bring those laws, use it to solve problems involving indices. So without wasting time, let's start with the first one. Multiplication law. So if you have a raised to the power x times a raised to the power y. Now, one thing you must know about using the laws of indices is this. They must have the same base. A and A, they are the base here. They must have the same base. If they are not the same, you cannot apply this multiplication law of indices. So because of these times here, you can apply that multiplication law of indices and say this is equal to A raised to the power of x plus, if there's a times here, you add the exponent. So you have a raised to power x plus y. Yeah, that's it. Okay, I hope that's clear. A raised to power what? X plus y. Please, let's like the life. There's no like yet. If you are with us here, kindly like the life. Thank you very much. Let's begin. Now, the reason you might be wondering, why is there any proof to this? Is it really possible that, because they have the same base and we're multiplying, then you add the exponent? Of course. So let's pick something simple. So let's say you have 2 raised to power 3 times 2 raised to power, let's say 2. This is equal to the same base, right? You add the exponent. So this is what? 3 plus 2. And this is 2 raised to power 5. What's 2 raised to power 5? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Then times 2 is what? 32. Now, if we don't want to, this is 32 right here. If we do not want to use this multiplication law of indices, what about if you just go straight and say, okay, what is 2 raised to power 3? 2 times 2 times 2, that's 8. So you do 8 times. What is 2 raised to power 2? 2 times 2 is what? 4. What is 8 times 4? 32. So yes, it's confirmed that the multiplication of indices holds true. It is very, very valid. Okay? Please, let's like the life. No like yet. My friends, please, let's like the life. Thank you for that one person that liked the life. Other people should join, please. Like the life. We are 18 on this life. Let's like the life. So that's the first law. What about number 2? Don't worry. I know this might appear very easy, but I just want to go through the basics before we start dealing with very interesting problems on indices. I got it covered. Don't worry. So let's look at another law. A raised to power y. Now let me just say x. This is the division law, divided by a raised to power y. So because we are dividing, mind you, the same base, right? The same base. So this will be equal to a raised to power x minus y. So for division, you subtract. For multiplication, you add. Same base. All right. So I will not want to bore you by proving every of this law. Okay. There's really no point. Once we get to the fun part where we have to start solving problems, then of course you see how useful these laws are. But for division, you subtract. Okay. Very good. So number 3, we have the 0 power rule. If you have a raised to power 0, this is equal to what? 1. A non-zero number. A non-zero number raised to power of 0 is 1. Not just, 0 raised to power 0 is undefined. This is not equal to 1. It is undefined. So please take note of this. A non-zero number raised to the power of 0 is what? 1. I hope this makes sense. Okay. Beautiful. All right. Yeah. Thank you for the managed side. Okay, thank you. You're welcome. Please, let's like the life. Just one like still, and we're 27 on this life. Okay, so this is another one. So let's come to I have them written here, but I don't want to lose track of any of them. So there's something called the power of a power rule. Power of a power law or rule. Power of a power rule. What does this mean? If you have a raised to power m bracket n, this is a raised to power m, and then, so this power is raised to another power. Power of a power. 2 powers. So if you want to do this, you simply multiply the exponent m and n. And this will be equal to what? A raised to power mn. You see that? So you multiply m and n, you get mn. A raised to power mn. So this is the power of a power rule. I hope this makes sense. So let's quickly do a test here. Let's say you have 2 raised to power 3, and then with the exponent of 2. So using this law now, this is going to be 2 raised to power 3 times 2. That's what? 6. And what is 2 raised to power of 6? That's 2 times 2 times 2 up to 6 times, right? That would be what? 64. That's 64. How about if you don't want to use this power of a power rule and you just want to do it without using that rule? What are you going to have? So let's just do, what is 2 raised to power of 3 without bringing this one yet? Is it not 8? So you have 8. And then we still have the exponent of 2. And 8 raised to power 2 is 8 times 8, which is what? 64. Same as what we have here. So this law holds true. Please, let's like the live. Thank you. Oh, 40 of you. Wow, so good to have all of you here. So good to have you. Please, let's like the live. Let us like the live. Let's like the live. Thank you, all of you. So if you have any question, ask before we move on. Based on the laws, we still have about 4 other laws to consider. If you have any question, ask before we move on to others. If you have any question, ask before we move on. Thank you for liking. Thank you for your support. Yeah. If you have any question, ask. Let's like the live. Let's like the live. Okay, I think we can move on now. So we have 4 laws already written down. Hope I can take this off. If you want to take a screenshot, do so. Let me just wait for a few seconds. Take a screenshot so you can have laws. Okay, so let's move on. So we stopped at power of a power rule. We'll continue with number 5. Number 5. And if you have been following me for a while now, you realize that I have been talking about my paid class. It's still ongoing. You can still join us, okay? You can still join us. So now we want to talk about the negative index rule. Negative index rule. Negative index rule. What do you mean by negative index? Look at n. N is index or exponent, but we have a negative sign there. So negative index, it means an index that is a negative number. This can be written as 1 over a raised power n. Yes, you can do like this. So a raised power negative n is equal to 1 over a raised to the power of n. This is the negative index rule. I hope that makes sense. Okay? Yeah. And thank you. Thank you for the like. Thank you. So this is the 5th law. And you know what? In fact, I want us to try out something. Let's say you have 2 raised to the power 3 over 2 raised to the power 4. You know, this is divided, right? And if you want to do this, this is equal to what? What is 2 raised to the power 3? That's 8, because 2 times 2 times 2 is what? 8. So 8 over. What is 2 raised to the power 4? Is that not? That's what? 16, right? Good. So 8 here is 1, 8 here is what? 2. You have 1 over 2. I want to prove this law now. If you have, see, this is 2 raised to the power 3. You know, I told you about that division law. This is divided, right? So I can just write it like this. And then bring in that division law. When I say if you are dividing, you subtract the exponent. So this is equal to what? 2 raised to the power 3 minus 4. Division, you are subtracting. And what is 3 minus 4? That's what? Negative 1. If you now bring in this negative index law, see what I have. If you have a negative index, it will become 1 over a raised to the power n. So that will be this negative sign now. The negative sign attached to the index will be 1 over 2 raised to the power of what? 1. Or just 1 over 2. Which is the same thing as what we got here. So I've just proven that the negative index law, when you have a negative index, you will take the reciprocal of the base with the exponent. So even if you have 4 raised to the power 1 over negative 2, this can be written as 1 over 4 raised to the power of 2. This and this are the same. Why is it 1 over the reciprocal? Because of this negative sign attached to the exponent. So this is how it works. Are you with me? Okay, if this is making sense, if you are enjoying this life, please let's type 1 in the comments. If it's going very well and you are getting value from this life, please let's type 1 in the comment. And please do not hesitate to like the live. You say I will be teaching basic maths. It's this is 10, but I teach advanced anyways. I won't call this one advanced. It's just around the middle. It's, should I say, middle school maths, not basic, not advanced. Okay, this is middle level. All right, so we are done with the 5th law. let's move on to the sixth law. We need to keep track of everything we've done. So we have the fractional index. Let me write this here. Fractional index law. Look at this word, fractional. It's fraction. So when you have a fraction as the exponent, let's say you have x raised to power 1 over a, this can be written as what? T. The one here, the numerator is the power, while the denominator is the root. So this can be written as what? The 8th root, a root, or 8th root of what? X. So this and this are the same. This is the fractional index law. You can write all raised to the power of 1 because of this 1 in the numerator, but we don't have to do that because it will still give us the same result. So let's pick a simple case. Let's say you have 4 raised to the power of 1 over 2. This is also equal to what? The square root of 4. You don't even need to write 2 here. This square root is coming from the denominator we see here. So the square root of 4 is what? Is 2. So this is how this law works. The fractional index law. The fractional index law. What about if you now have something like this? If you have, let's say, x raised to power b over a. Now you see, b is not 1. Well, it can be 1, but in this case, we are not taking it to be 1. A is also not 1, all right? Even though it can be 1, but we are not making it 1, all right? So give me a minute. Let me switch this thing. Okay, so look at this. Like I told you, if you have a fraction as the exponent, the denominator is the root, while the numerator is the what? Power. Let me say it again. This one is the root, while this is the what? Power. So this can be written as what? The 8th root of x. The 8th root of x, all raised to the power of what? B. The 8th root of x, all raised to the power of b. So this is how this law works. Let's look at a simple case. So let's say you have 16 raised to the power of 3 over 2. 16 raised to the power of 3 over 2. How would you work this out? How would this be worked out? So this is equal to what? I told you before, when you have a fraction as the index or as the exponent, the denominator of that fraction is the root, while the numerator is the what? Power. So this is equal to what? The square root. You can write 2 here or not. You don't have to. Of what? 16 raised to the power of what? 3. You see that? You tell me, what is the square root of 16? That's 4, because 4 times 4 is 16. So you have 4 raised to the power of 3. And 4 raised to the power of 3 is also what? 4 times 4 times 4. So you are multiplying 4 by itself 3 times. 4 times 4, 16. Times 4 is what? 64. So this is how this fractional index law works. If you have any question, please drop it in the comment, and let's type one. Let's type 1 in the comment if this is making sense, if we are getting value from this video. Type 1 in the comment and like the live. Thank you for those who have liked it already. For those who are yet to like, kindly like the live so other people can join us. Please drop your question if you have any in the comment. We are still covering the laws of indices. We are still talking about the laws of indices. I hope you are getting value from this. Thank you for those who are liking the live. Thank you, thank you, thank you, thank you. Okay, I think we can move on to power of a product rule. I have to clean this. If you're taking a screenshot, just let me wait for a few seconds while you take a screenshot. All right, time up, time up. Let's go to this 8 law. Is it 8 now? I've lost count already. Or maybe 8 here, but it's fine. Now, the numbers don't even matter. You can actually just start with any of them. But usually we want to start with the multiplication, then division, and it just keeps going like that. Okay, so let's talk about the power of a product rule. I think this should be the 8th law. The power of a product rule. So let me explain this. let's say you have A times B. A and B, they are the product of AB, right? They are the, if you multiply A and B, you get AB, yes? So the power of a product, A and B, like A and B is the product. So let's say you have M here. Do you know that because of this bracket, this M can be distributed to A and B? So this is what we call power of a product. Where is the product? AB. Power of a product rule, power of a product rule. This is equal to what? You distribute this X and B. So this will be equal to A raised to power M times B raised to power what? M. See what I've just done? I've distributed the power to the product in the bracket, AB. How would that make sense? How would that make sense? Okay. What about 16 to the power of 2 over 2? 16 to the power of 2 over 2. 16 to the raised to the power of 2 over 2. Like you mean this? If this is what you mean, you can divide like this. And that will still be what? 16 raised to the power of 1, which is also 16. If this is your question, it's been answered already. Please, let's like the life. Thank you for those who are supporting this life. So this is power of a product rule. This is how it works. Let me quickly explain this using real numbers. So let's say you have 2 times 3. This is times, by the way, it's dot. It's not decimal point. If it is decimal point, I should have dropped it here, but it's at the middle, so it's times dot. So let's say you have this raised to the power of 2. Using this law now, this power of a product rule, this should be equal to 2 raised to the power of 2 times 3 raised to the power of what? 2. You see that? So this is equal to, what is 2 raised to the power of 2? That's 4. So 4 times, what is 3 raised to the power of 2? That's 9, because 3 times 3 is 9. And what is 4 times 9? That's 36. If we do not want to use power of a product rule, here's what we're going to do. Remember, 2 times 3 is what? 6. So that's 6. Then with the exponent of what? 2. What is 6 raised to the power of 2? It means 6 times 6, which is what? 36. Same as what we got here. So it works very well. Power of a product rule works very, very well. I hope you're getting value from this video. I hope it's making sense. Okay, let's like the life. Let's like the life. Let's like the life. Can you teach me how to add scientific notation or divide? Don't worry, we will get there. And if you want more lessons, you can always join my paid class. If you want more lessons tailored to preparing you for final exams, O-level final exams, you can always join my paid class. This is the free class, but I have a paid class, especially for those who are making a financial commitment to join my inner class. If you want that, you can send a direct message. There's a link on my bio that you can click, and it will take you directly to my WhatsApp, or there's a link on my bio that you can go to my website where you can make payment for the paid class. All right, so I think we can move on. We have, so it's been fun looking at these laws. Let's look at one more. I think I have to clean this. Yeah, let's take this off. So we have one, power of a quotient rule. So let's say you have A over B. This is quotient now, A divided by B raised to power M. Again, as we did in product, power of a product rule, this becomes what? A raised to power M. You distribute the power to A and B. So this should be A raised to power M over what? B raised to power M. This is how this law works. All right. So I've been able to cover 9 laws of indices, and it's been fun so far. I'm sure too you can agree with me that we've had a wonderful time looking at these laws of indices. So if you have any question, please ask. Please ask. Just give me a few seconds. Let me go grab water to drink. We now want to look at some problems on indices. So I think we're done with all of this. The laws of indices, we're done with that. Okay, interesting part. So examples. Number one. Of course, we'll start from the very basic ones. So now, of course, you know what law we can use here. Who can tell me in the comment, which law are we going to use here? I know it's very basic for many people, but again, I just want to see if you are with me. Which law are we going to use here? If you know it, type it in the comment. Who knows it? Which law are we going to use? Powers will be added. Thank you. So this will be equal to what? This will become 10 raised to the, because we are multiplying 1, 2, because they have the same base. So we add the exponent, the power. So 2 plus 3. And this will be equal to what? 10 raised to the power of what? 5. And if you want to write it in ordinary form, you can just say this is what? How many zeros? 1, 2, 3, 4, and 5. But this is actually okay. It's just fine leaving it like that. So that's the first one. Okay, we'll just quickly run through this because this is quite straightforward. And if you have any question, please do not hesitate to let me know, okay? And thank you for your support, for liking the live, and for everything. So now look at what we have. See, many students make this mistake. See, we have n and n, same base. However, 22 and 2 are not the same base. So we can just bring those numbers out. We can separate them. So this is what we're going to do. Please take note of this. I can write this as what? 22 over 2 or divided by 2. Then we'll now use the law of indices for n raised to power 7 divided by what? N raised to power 3. This is what I just did now. I brought out the number 22 and 2. We're dividing both of them, right? Then the law of indices will be used here. However, you can even choose not to use the law of indices, but you just have to cancel. When you have n raised to power 7, you have n times up to 7 times. So, but since we have a smarter way of getting our answer, why can't we just do that instead? Right here. So what is 22 divided by 2? That's what? 11. So this is 11. Then use the law of indices. You are dividing, same base, you subtract the exponent. So this will be what? N raised to power 7 minus 3. Divided, you are subtracting the exponent. So this is 11 what? N raised to power 7 minus 3, that's what? 4. So this will become your answer. I hope this is okay. Yeah, thank you, Nikki. Sorry, I may not be able to get your name very well. Nikki Vyas, thank you very much. So this is your answer, 11n raised to power 4. Okay, so we are through with this. I hope you are following. I hope you are taking your screenshots. Hope you are asking your questions. Please make sure if you are here, because you are giving me your time, your attention, and your energy, make sure you utilize it very well. How? Ask questions, participate, put your feedback in the comments so you can get the value from this live class, okay? And again, if you want to be informed when I come live, you can always join my community on Telegram, on WhatsApp. WhatsApp channel is also there. Once you get to the link on my bio, click it, it will redirect you to my Telegram channel or WhatsApp group or WhatsApp status. It's all there. You can quickly go there and join my community. Don't worry, that one is free, but we have a paid class also. Okay, so this is what we have. We're done. Let's look at another example. It's getting more interesting. I'm sure you can agree with me. So we'll look at 2 examples. We have so many here. Don't worry, I got it covered. So this is 19 raised to the power of 0. Who can tell me what would this be? It's just a very simple answer. What is 19 raised to the power of 0? Who knows it? Can you drop it in the comment? Oh, 1. Nikki VR. Thank you. We divide, we subtract the powers if the base are the same. Yes. Thank you. Yeah. So this is what? 1. This is equal to 1. That's all. So this is the 0 power rule. Even if you have 1 million, hope I write this way. This 1, 2, 3, even if it's 1 billion, 1 trillion, as far you have raised power of 0, it still becomes 1. And you don't have to feel sorry for making all of these 1 because it has a 0 power. It's 1, right? It's 1. So no worries. Okay, let's go to another example. Where are we? Okay, number 4. This is now the negative index law. Who can tell me what this will be equal to? Don't worry, I know some of you already know it, but I also want to, make it more interactive. If you know the answer to this, can you just type it in the comments? If you know the answer, can you type it in the comments? 1 over 25. Isn't that beautiful? Thank you for participating in this live. Yeah. So 5 raised to the power of negative 2. For those who don't know, we've talked about the negative index law. Because you have a negative sign here attached to the index, you can take the reciprocal. By that I mean, since it's 5, you can make it 1 over 5. So 1 over 5. However, you have an exponent of 2. So raised by 2 there. 1 over the reciprocal of this number here came from the negative sign attached to the exponent. So finally, you just have 1 over. What is 5 raised by 2? 5 times 5, which is what? 25. So this is your answer. Any question? Drop it in the comments. So it's getting more interesting. So look at this one. 2 raised to the power of 3 times 1 over 6 raised to the power of negative 1. You know what's going to happen? I'm going to wait for a few seconds for you to provide the answer to this question. Let me just wait. Don't worry, I'll still do it, but I just want you to tell me what this is. You can work it out in a few seconds and drop your answer in the comments. Okay, so reciprocal, yes, Nikki, yes. 6 over 8, okay. Are you sure about that? Remember, there's a negative sign here. There's a negative sign here. Somebody said 48, okay, interesting. What chapter is this in math? Sanat Kumars. This is under indices. See the topic there, indices, okay? And this is in grade, this should be grade 10, grade 11. Yeah. Though grade 9 can also, it's also, I think it's been introduced in grade 9, but this, what we're doing now, it's around grade 10, grade 11. I should just say grade 10, yeah, grade 10. So let me now work this out. 2 raised to the power of 3, see. For those who are wondering, this 6 cannot be expressed as a power of 2. Well, it can, but you will not have a whole, an exponent that's a whole number. All right, maybe 2.2 raised to the power of a decimal number. So, but we don't want to do that at all. See, 2 raised to the power of 3 means 2 times 2 times 2, which is 8. So you write 8 here times. What about 1 over 6? But we have a negative sign there. This negative sign, we take the reciprocal of the number. So when you take the reciprocal of 1 over 6, it's like this is 1 over 6, right? If you take the reciprocal, that will become 6 over 1, which is also 6. Yeah? So this one is 1. If you write 1 here, it doesn't change anything. So what is 8 times 6? 48. So those that said 48, they are correct. Great job. Yeah, Naya J, yes, it's actually grade 10. Yes, grade 10. So Tifinas, yes, it's correct. 48 is the answer. Okay, I hope you are getting value from this video. If this is making sense, if you're enjoying this video, please don't forget to like, don't forget to share this live to others so they can participate. Okay, we have some more interesting questions. Yeah, number 6. Yeah. And see, let me just even say it right here. I might be live this night. If I say this night, I don't know if my night will be your night. So West Africa time. I'm from Nigeria, okay? I'm from Nigeria, and we use the West Africa time. So you may want to calculate that with your own time. All right. So that's why you need to join my group so that you have access. You'll be well informed when I come live. I think I'll just leave it at that. So this is another problem we have. If you know the answer, drop it in the comments. Oh, thank you, Sanat, for the feedback. Thank you, Sanat Kumas. Thank you very much for that feedback. It means a lot to me. Thanks for the feedback. So who knows how to do this? See, they have the same ways. RRR. right? They have the same grades. What is it going to be? Okay, we already have an answer here. Somebody said 1 over r raised by 4. Okay. Okay, I think this is good. R raised by negative 4. Okay. Nikhil Vias. Okay. Yeah, I think both of you are right. Okay. So how do we solve this? See, there's an exponent of 1, even though it's not written there. Because even if you remove it, it changes nothing. So let's just put it right there. Times, same base, we're going to add the exponent. So you have 1 plus what? 0 plus negative 5. You can wrap it in a bracket if you want aesthetics. So this is what r raised by 1 plus 0 is 1. 1 minus 5 is what? Negative 4. So because we already know the negative index law, we just want to shine it through here. You can leave it like the ball. Let's prove that we know the negative index law. And what would this be now? You take the reciprocal of r raised by 4. So you have 1 over r raised by 4. So this becomes your answer. I hope this makes sense. So for those of you who said this is the answer, yes, you are right. You are correct. You write it as, okay, yeah. For which course is this for, guys? And we have, this is for students in high school. Yeah. Okay, I think it's time to give you some work to do. But I'm beginning to feel that this exercise I'm about to give you might be. Don't worry, I'll still give it to you. Yeah. Can I take this off? I think I can take this off, right? So let me take this off. Let me take that off. Here's some questions for you to try out. Don't worry, I'll still work them out with you. We have to simplify the following, by the way. Simplify the following. I hope you're still with me. So number 1, what do we have? We have 5y times 4y raised by 4. Number 2, we have 3x raised to the power of negative 3. Okay. Number 3, we have 9a raised by negative 5 times 4a raised by 6. Number 4, we have 15 times 10 raised by 4 divided by, yeah, we have to do this in case you're wondering. Okay, for 4 questions for you to play with, for you to give it a shot. Yeah, who's giving me the answer to the first one? Oh, I can see answers already in the comment. This is beautiful. You guys are on fire. You guys are on fire. You're on fire. You're on fire. Okay, solution. So let's start with the first one. Number one. Who is there? What's up, guys? Sorting Finas, yes, 20 wires per 5. That's so beautiful. Yeah, that's correct. That is correct. Please, if you are putting the answer, just write the number, like what Vowelzm did. He deduced number 1, then wrote the answer. Please, let's do like that so that we'll know what you are answering. So for number 1, you are right. You multiply 5 and 4. That will be 20. So you do 5 times 4. And then you apply the law of indices here. This is y. You know, there's a power of 1 there. There's an exponent of 1, even though there's no written. So 1 times you add 4. 5 times 4 is what? 20. So you have 20y. 1 plus 4 is 5. This is the answer to number 1. For those of you that said this, you are correct. Those who said it's 20y raised by 5, you're right. You are very, very correct. So for number 2 can be tricky. We have to be very careful. You have to be careful with number 2. All right. So let's have the answer. Please, if you have written it before, I may not have seen it because I was busy doing number 1. Please, let's put the answer to number 2 in the comment. Let me see. Vox 1973. Thank you. But we're done. You're done writing. You've answered everything. Oh, okay. If you're done writing, you might have to rewrite. Okay, so this is 3x all raised to power negative 3. You know, I told you that this bracket, when you have this bracket like this, and you have a power, make sure you distribute that power. This is actually power of a product rule. Yes, power of a product. But before I do that, this negative sign will make me to take the reciprocal of 3x raised to power 3. So see, 3x raised to power negative 3 will be equal to 1 over 3x raised to power 3. Yes, this negative sign 1 over. Okay, so we have the, now we're going to apply the power of a product rule. Power of 3x, that's product, 3 times x in the bracket. So you distribute this exponent to 3 and x. So this will become what? I hope you can still see what I'm writing. So, okay, let me just wrap it up here. 1 over 3 raised to power 3. You see that? And then x raised to power 3. I just distributed the exponent to 3 and x. Finally, your answer is going to be what? 1 over 3 raised to power 3 is 27. 3 times 3 is 9. Times 3 is what? 27. So 27 x raised to power 3. If you got this, beautiful job. Great job. If this is what you got, great job. Oh, Anubav, you already written the answers. Yes, 1 over 27. Yes, that's correct. Thank you for dropping your feedback. So this is the answer. For those of you who could not do it, this is the answer. Please take a screenshot. I'm about to go to number 3. Okay, we're done with that. So let's go to number 3. I think I'll just, let me just clean this and still maintain it here. So number 3. See, 9 and 4, just multiply because of these times. 9 times 4, all right? And you can wrap it in a bracket. Now use the law of indices for a raised to power negative 5. Because we are timesing, you add, then raised to power 6, all right? And this is equal to 9 times 4 is 36. A raised to power what? Negative 5 plus 6 is what? 1. So this is the answer. You can just do away with the 1 and say, yes, the answer is 36A. And you'll be well on your way to the right answer. So we are working with power rules. Oh, yeah. For this, for number 2, power rules. Well, okay, you mean law of indices. Okay. If that's what you mean, yeah, that's it. So number 4. Okay, who was able to do number 4? So if I want to do it, by the way, I can just say 15 divided by 3. 15 divided by 3, you can wrap that, and do 10 raised to power 4 divided by what? 10 raised to power negative 2. You can also wrap it like this. Makes sense. 15 divided by 3 is what? 5. So times, what about this? 10 here, we're dividing. So you subtract the exponent. See, you have to be careful. Who has even got a number? Let me even check. Who has got it? Are you sure? Hey, are you sure it's negative 6? So to finance, are you sure it's negative 6? That 4.5. Why did it say number 4? Are you sure it's negative 6? See, this can be very, very tricky. Wait, what's going on? This is negative 2, by the way. Yeah. I'm glad you have seen it now. I'm glad you have seen it. So divided, you subtract. This is negative 2. You can just wrap it in a bracket like this for easy. I like to call it aesthetics for distinction, right? So this is equal to what? 5 times 10. This is 4. Negative, 2 negatives. Minus times minus is what? Plus. So you have plus what? 2. Finally, you're going to have 5 times 10 raised to power what? 6. So this is your answer, okay? If you have any questions so far, please ask. How would you go live? How would I go live? Wait, I'm coming. Somebody asked a question. He said, if 1 raised to power 1 is 1 and a raised to power 0 is 1, that implies 1 raised to power 0 is which tells you. Well, you are not doing it the right way. We could go back there and prove that thing. Because if you say a raised to power 0 is 1, right? Remember, when we say zero product rule, it has to be a non-zero number. So you cannot say 0 is plus 0 is equal to 1. No, 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 no. This is not true. All right. So if I saw what you did there, you brought in 0 somewhere. No, you can't do this. Okay. So this is for number 4. How far do I go live? Well, I might say I don't really have a structured time, but I'm trying to work on that. However, I would advise that you join my community. The link is on my WhatsApp channel. Sorry, the link is on my YouTube channel. You can go there, click on my bio. Either you join the WhatsApp group or you join the Telegram channel. Anyone you want to join, it's fine. So that's how I can answer that. But I asked for 1 is plus 0. Maybe let me take a screenshot of what you just said now. I don't want to be distracted with that. Okay, so that's that. Let's move on to other things. Yeah. And by the way, like I said before, a non-zero number raised power of 0 is 1. A non-zero number raised power of 0 is 1. Yeah, I hope I don't want to stay too long because I'm completing an algebra course and this is very entertaining for me. Oh, well, thank you. This is really great. Really great. So I think we're going to let's do some more examples before we end the live. I don't know how long I've been here, but I think it should be over 1 hour. Okay, so not up to 1 hour, I've just been told. So look at some more examples. Here is part 3. So don't worry, we are getting to the fun part. You are going to love it. You're going to love it. So look at some more examples. Most of these ones, see, this is what we call the power of a power rule. We've talked about this when we were examining the laws of indices. So let's start with the first one. Easy. Power of a power rule. Power of a power. You just multiply. 2 times 3 is 6. So the answer becomes what? 2 times 3, which is, sorry, not 2x. And that's x raised to the power. 2 times 3 is what? 6. So number 1 is x raised to the power of 6. I want all of you to try number 2 and drop it in the comment. It's just very similar to what we have in number 1. Let me have your answer for number 2. Yeah. Thank you, Shivanchu. Yeah, good to have you here. Somebody said 15. Why did you say 15? It's not just 15 now. Yeah, a raised to the power of 15. Okay. Yeah, don't just write 15 because you have a as the base. So for this, you have a raised to the power what? 3 times 5. 3 times 5. Hope this is well written. That's a raised to the power. 3 times 5 is 15. There you go. Number 3, see what we have. See what we have. Who wants to give me the answer to number 3? The final answer, just simplify it to the simplest form. Simplify it to the simplest form. Number 3, who is there? Who's giving me the final answer? The final answer. 2 raised to the power of negative 6. Okay, but can you do something else? Shavankuma, Sashinkuma, can you do something else that will not give you your final? Still simplify it further. You have a negative index. Why not use the negative index law or rule? Yeah, who wants to help us out? Use the negative index law or rule. Are we ready for that? So you have 2 raised to the power of negative 3, then 2. Yes, you already said 2 raised to the power of negative 6. Is there something you can do more than that? Somebody said 4 raised to the power of negative 6. How did you get that? Why not use the power of a power rule? You multiply this and this. Okay, so this would be 2 raised to the power of negative 3 times 2 is what? Negative 6. But we can still do something, because if we do not want that negative sign hanging around there, let's kick it off. What do we do to remove this negative sign? You can talk to me in the comments. We want to kick off. Somebody already told me 1 over 64. Isn't that beautiful? Isn't that beautiful? So this negative sign here, we take the reciprocal of 2 raised to power 6. So see what we have. However, you can say finally this is 1 over 2 raised to power 6 is what? 2 times 2 times 2 times 2 times 2 times 2, which is what? 64. So that's your answer, 1 over what? 64. I hope this is making sense. Is somebody getting value here? Type 1 in the comments if this is making sense to you. If this is making sense, you type 1 in the comments. Yeah, the answer is 1 over 64. Okay, people, do number 4. Don't allow these negative signs make you shiver. There's nothing there. Yeah, thank you, France Furlong. Thank you. Somebody said 81. Somebody said 81. Are you sure it's 81? Okay, that might be right. Answer for 4 is 81. Okay. Thank you for that. So let's quickly look at number 4. Because I need you to see what I'm writing, it seems the comments are already blocking this part of the board. So let me do number 4 here. Don't worry, for those of you that say 81, I think you are right. I think we're on the same page. So number 4, this is it. 3 raised to power negative 2, power of a power. You multiply these 2 powers. Negative 2 times negative 2 is what? 4. So this is what? 3 raised to power 4. And 3 raised to power 4 means 3 times 3 times 3 times 3. Which is what? 3 times 3 is 9, times 3 is 27, times 3 is 81. So this right here is what? Just 81. And there you go. There you go. All right, we have some. Okay, let me see what I have here. Okay, so before we end this lesson, because I have to bounce. To bounce means to end the lesson. I have some more examples which we'll just do and then end today's lesson. I hope this lesson has been fun for you. I hope you've gotten some value from this lesson, from this live session. If you want more of this, and if you want to join my private community where you get loads of math lessons and assessment that will help you become much better and prepare you for your exam, you know what to do. The link is on my bio. Send a message on WhatsApp. We'll work out how you will get enrolled in my paid class. Okay, so some more examples before we end the lesson. Simplify the following, as usual. Simplify the following. So number 1, we have minus 3 d raised to power 3 all raised to power 2. Number 2, we have minus 3 d raised to power 3. Now you have to be very careful with all of this. It can be tricky. Number 3, we have minus 4 c raised to power 5 raised to power 3. And finally, we have a raised to power 3, b then raised to power 4. These are our questions. What time you teach, sir? I like this teacher, dude. Like, for real, he put too much effort. Yeah, thank you for the feedback. Thank you so much. All right. So, number 1. Number 1. See, you must know that what you have in the bracket are being affected by the power. So this is what we call the power of a product rule. Negative 3 d raised to power 3 are being affected by the exponent of 2. So you distribute these 2 to negative 3 and to d raised to power 3. Take note of that. Take note of that. All right? I see answers here already. Somebody already... These guys, you are really doing great things. Number 1, we distribute the power to the product in the bracket. So this should be minus 3. Please be careful with this. I can write it like this. Minus 3 raised to the power of 2. And then d raised to the power of 3 raised to the power of 2 again. Because this 2 will be distributed to negative 3 and d raised to the power of 3. Hence, I have this. Hope that makes sense. Minus 3 raised to the power of 2 means minus 3 times minus 3. So minus times minus is plus. 3 times 3 is what? 9. So this is 9 already. Hope you are flowing with what I'm doing here. And then you have D. Again, you know, this power of a power rule. And 3 times 2 is what? 6. So you have raised to the power of 6. This right here is your answer. 9D raised to the power of 6. How does this make sense? Any questions? So number one, how many of you got this one? 9D raised to the power of 6. How many of you got number 1? Just type 1 in the comments. If number 1, if you got number 1, type 1 in the comments. France Forlong, okay. Thank you. Hi to you too. Shivanshu, 9D raised to the power of 5 or raised to the power of 6. Please, can you correct that for number 1? It's not raised to the power of 5, it's raised to the power of 6. You are multiplying. 3 times 2 is 6. Oh, okay. Yeah. It was the type error. Yeah. Okay. Yeah. So for number 2, can we look at number 2 together? Who has done number 2? I think I can do number 2 here. Let's just create a space here for number 2. Look at this. See, look at this. This 2 does not affect negative 3. It only affects what we have in the bracket. So don't go and put negative 3 raised to the power of 2. That would be wrong. So see, it is negative 3 times, if you like, D. So you now do 3 times 2. What's that? 6. Finally, you have what? Minus 3D raised to the power of 6. There you go. That's your answer. For number 2, yeah. Okay, number 3. I hope I'm not too fast. Number 3. This is minus 4G raised to the power of 5 raised to the power of 3. This 3 will be applied to everything you have in the bracket. So this will be what? Minus 4 raised to the power of 3. You see the way I am distributing the powers to the product in the bracket. And then you have G raised to the power of 5. You can do this as well. You see that? And then minus 4 raised to the power of 3 means minus 4 times minus 4 times minus 4. So let's break it down. What is minus 4 times minus 4 times minus 4? Minus 4 times minus 4 is what? 64, because minus times minus is what? Sorry, minus 4 times minus 4 is 16, because minus times minus is what? Plus. So what is 16 times minus 4? 16 times negative 4 is what? Negative 64. You see that? Yeah, so that's negative 64 there. Then this is 5 times 3. What's that? 15. So G raised to the power of what? 15. That's your answer for number 3. Makes sense. Finally, number 4. Number 4, what do we have? Again, we distribute the power to the product in the bracket. Power of a product rule. So this will become, let me just write the question here again. So this will be equal to A raised to the power of 3 with the power of 4, with the exponent of 4, then B raised to the power of 4. Finally, you have A raised to the power of, what is 3 times 4? That's what? 12. So 12, and then B raised to the power of 4. That right there is your answer. I hope you're getting value from this video. Yeah. So thank you, Shivanshu. Yeah, that's the correct answer. A raised to the power of 12, B raised to the power of 4. Yeah, for those of you who put your answer in the comments, I hope you were able to reconcile your answer with what I got. And I want to believe I am right with all the answers. But if you feel I am wrong in any of them, you can just bring my attention to it. Oh, good delight. Yeah, beautiful. That's correct. So we're going to end the lesson right here. And if you have any question, you can quickly drop it in the comments. For those who are asking, how often do I come live? When will I be coming live next time? If you want to know when I'll be coming live next time, join my community on WhatsApp and on Telegram. Again, if you want more of this lesson, you want assessment, you want to be better prepared for your final exam, O-level exams. We have BEC, that's junior school. We have those in primary school, getting entrance into high school. I have you all covered. If this is what you need, there's a link on my bio where you can send me a message on WhatsApp, or there's a link where you can go to my website and make a purchase so you can be enlisted in the private class. The ball is your court. You can always join me either in my free group or my paid class. Of course, for the paid class, you get more of this. You have access to video lessons recorded. You have access to weekly tests and assignments, and also, of course, weekly classes as we have like this. So it's loaded. You have more value for joining my paid class. If you want more of that, make sure you join my paid class. Thank you all for joining. I will see you next lecture on which topic. Yeah, we just started this topic. We have a lot on indices to be covered. You know, when I take a topic, I like to go deep. I like to go deep into the topic. So make sure you stay tuned for my next live session. I don't even know. I might even come live tonight. Again, I'm still trying to work out my schedule when I come live. It still depends on my other activities, how free I am. So if you want to be well informed when I come live, not always, join my community on WhatsApp and on Telegram. Thank you for your time. Hope to see you in the next one. Bye for now.